Hello guys, welcome to the channel H2O, the A to Z of chemistry. Today, to make the study of inorganic chemistry very easy for you students, we are going to put up a topic from group 15 elements, and that is going to be phosphorus. So phosphorus, we have some oxoacids. There are many of them, and you have to know the names and the formulae for all of them, which the students find it very difficult. So today I'll be giving you a trick which is going to make the study really very easy. And trust me, this is very important for JEE and NEET examination. So you should have a thorough understanding of it. You should know all the names and the formula of the oxoacids of phosphorus. Next, I will also be putting up the structures for these oxoacids. I will also be giving you the names and the formula of the oxoacids of sulfur, the halogens also in the upcoming lectures. And that is going to be really very helpful for you for your examination. So please do subscribe to the channel and click on the bell icon so that you can even get the notification when I will be putting up the next lectures from this series. So now let us begin the learning in a very easy, interesting way. So let us start the learning with understanding the term oxoacids first of all. So oxoacids, these are also called as oxyacids, and as the name suggests, it is going to be oxygen containing acids. So what is the definition for these compounds? Well, these are going to be those compounds which contain hydrogen, oxygen, and at least one more element which is going to form a bond with the OH group. So the simplest oxoacid which we can have is going to be ZOH, where Z is going to be any other element apart from oxygen and hydrogen. Now, why is this OH group so very important? Because oxygen is highly electronegative and hydrogen, this is going to be electropositive. So this bond can break very easily. Why do we need to break this bond? Well, we need to break this bond. We need to dissociate this to produce H ions, which are responsible for the acidic characters of a compound. So these compounds in solution, they are going to produce H ions and the corresponding anion of the acid. So what we will be getting is ZOH on dissociation producing HZO negative and H positive. What is the general formula for these compounds? Well, the general formula is going to be HXZYOZ. So all the three elements, hydrogen, the Z element, which can be any element, as you will be seeing the examples which elements can form oxoacids, and we can have oxygen to be in varying numbers. All right. Now, which are the elements which can form these oxoacids? So I'm going to give you a few common elements which form oxoacids. Along with that, I'm going to give their highest oxidation number. Why the highest oxidation number? Just now I'll tell you. So the common elements which form these oxoacids, these are the p block elements. Generally, these are non-metals which are forming these oxoacids, but this does not mean that these are the only compounds that the elements which form oxoacids. D block elements, for example, manganese, chromium, these do form oxoacids as well. Here we are just talking about the common ones, the common P block elements which form these oxoacids, which are very importantly asked in the examination. Alright, so we have boron, carbon, silicon, nitrogen, phosphorus, arsenic, sulfur, selenium, tellurium, chlorine, bromine, iodine being the common elements which form oxoacids. Now, why have I listed the highest oxidation number? Because these elements, they can show variable oxidation states. For example, if I talk about nitrogen, nitrogen can show an oxidation state from -3 to +5. And in these oxidation states, well, these elements, they form a number of oxoacids. And for naming these compounds, writing the structures of these compounds, you should have a knowledge, first of all, of the highest oxidation number. Alright, now the highest oxidation number is going to be which for these elements? It is going to be equal to the number of valence electrons for these elements. For example, boron, this is what group? This is 13th group of the periodic table. So 13 minus 10 for the D block elements, you are going to get 13 minus 10 to be 3. So boron, this has 3 valence electrons and it is going to have the highest oxidation number to be plus 3. Similarly, the carbon family, group 14 minus 10, 4 valence electrons, highest oxidation number is going to be plus 4. Similarly, nitrogen, phosphorus, arsenic, 15 minus 10 would be 5. So highest oxidation state is 5. For the oxygen family, it is going to be 6. And for the halogens, it is going to be 7. So these are the highest oxidation states for these elements. And these are the common elements which form oxoacids. Now, how do we name these compounds? Now, one thing that you have to understand is why we are learning the naming of these oxoacids. Well, it is because, first of all, as we've just now talked about, is that the elements which are forming oxoacids, they can have variable oxidation states. So according to those oxidation states, they can form a different type of oxoacid. Other thing is that these elements, hydrogen, oxygen and the Z element, they can be varying in number, and with the difference in the number of those, well, we are going to have different oxoacids. So because of that, it is very, very important that you learn the correct way in which these oxoacids, they are named. Alright, so for that what you have to learn is that we are going to use certain suffixes and prefixes in the naming of these oxoacids. And first of all, essentially we have two types of parent acids whenever we are naming the oxoacids. The parent acids, these are called as the ic acid and the us acid. For example, we have HNO3 to be called as nitric acid and HNO2 to be called as nitrous acid. So this is ic acid of nitrogen and this is us acid of nitrogen. In both the acids, you can see that we have hydrogen, nitrogen and oxygen. So naming them differently was required. Now, why is HNO3 called as ic acid and this as us acid? Why not the opposite way? For that, what you have to find out is the oxidation state for these elements in the two acids. So in HNO3, what you will be seeing is that when we are going to find out the oxidation state of nitrogen is +1 for hydrogen, plus X for nitrogen, we have to find it out, and oxidation, this has the oxidation state of -2, so 3 into -2, so this will be -6 plus 1 and it will come up as +5. And on the other hand, for HNO2, what you can see is that the oxidation state of nitrogen, this is going to come as +3. So from this, what we are going to generalize is that the ic acids, they are going to have a higher oxidation state than the us acid. And in fact, it is not going to be only for the oxoacids that we use this principle. Even for the naming of the elements, we use it. I hope you all know that iron, this has an oxidation state of +3 and +2 in the ferric and ferrous. So again, it is ic that is +3 and us that is +2. Similarly, if we talk about tin, tin is available again in two forms, two oxidation states. It is stannic and stannous. So ic is going to be +4 and us is going to be +2. Similarly, we have lead to be plumbic and plumbous, mercury to be mercuric and mercurous. So in all of these, what you find is that ic is used for the higher oxidation state and us is used for the lower oxidation state. So for the oxyacids also, we use the same principle. Easy enough to remember now. From ferrous and ferric, you have been doing that from so long. So now let us begin the learning of the oxoacids of phosphorus. First, I will be giving you a general plan where you can see the names of all the prefixes that we will be using for the oxyacids of phosphorus, and then we will be actually deriving the formulas for those compounds. Okay, and this plan that I'm going to give you for the various prefixes, well, this is going to be helpful for naming the oxoacids of other elements as well. So how are we going to start the naming? Well, we will be starting with the parentic acid, because I told you, if you remember the formula of the parentic acid, you will be able to derive the formulas for all the oxoacids. So the parentic acid, if you subtract one oxygen atom from it, what you will be getting it as a parent us acid. And this is going to be true not only for the oxoacids of phosphorus, it is true for the oxoacids of any element. For example, just now you saw the example of nitric acid and nitrous acid. So nitric acid was HNO3 and nitrous acid -1 oxygen, that is HNO2. Right? So this is going to be true for nitrogen, phosphorus, sulfur, halogens, all of the oxoacids. So you have started learning the naming of the oxoacids of other elements as well over here, along with the learning of the oxoacids of phosphorus. Alright, so now we have parentic acid and the parent us acid. So these are the two suffixes that we will be using. For other oxoacids, what we will be using is now the prefixes for them. The ic and the us is going to remain in them. Alright, so now from the parent us acid, if I remove one oxygen, what I will be getting is a hypo us acid. Okay, so you have a parent us acid. From that removal of one oxygen, you will be getting a hypo us acid. And if you remove one water molecule from it, that is, you are going to reduce the number of hydrogens by 2 from the formula of the parent us acid, and the number of oxygen atoms by 1 from the formula of the parent us acid, what you will be getting is a meta us acid. And on the other side, well, you can subtract from the ic acid one H2O also. And what you will be getting is a meta-ic acid, right? So meta-ic is going to be -1 water from the ic acid, and meta-us acid is -1 water from the parent us acid. Similarly, if you take two molecules of this parent us acid and subtract one H2O from that, what you will be getting is a pyro us acid. And this is also called as a di-us acid. And on the same way, the parentic acid, if you just take two molecules of it and -1 H2O, what you will be getting is a pyroic acid or a di-ic acid. You're finding them difficult? Do not worry. I'm going to repeat everything once again with the actual formulas for phosphorus. So then it is going to be learnt by heart with you people. Do not worry at all. Just listen to the names because this is the first time you're learning them. Fine. Now, the next is that we have the parentic acid. From this, when we are subtracting one oxygen, we got a parent us acid. So how will we get the hypo us acid for this? Well, we cannot do it because when we are removing one oxygen, it is the us acid. So where does the hypo go? Well, we will be talking about that also just now. But before that, what I want to do is I want to add one oxygen to this ic acid to give me another oxo acid. So parentic acid plus one oxygen atom, what you will be getting is a peroxoic acid. And peroxo, I hope you all remember from hydrogen peroxide, that peroxo is going to stand for a peroxy linkage. That means a O, single bond O bond is going to be present in the structure of a compound which has the name peroxo. Okay, so this is going to be peroxo when we have added one oxygen atom to the ic acid. Now let us talk about the hypoic acid. How are we going to name that? For that, well, because we cannot subtract the oxygen from the ic acid, what we will be doing is we will be subtracting one oxygen from the di-ic acid or the pyroic acid. So -1 oxygen from the pyroic acid, what you will be getting is the hypoic acid. And if to the pyroic acid you are going to add one oxygen, what you will be getting is the peroxodiic acid. Alright, so here also you will be saying that a peroxy linkage is going to be present. Right, so this is going to be peroxodiic acid, this is going to be peroxoic acid, or you can also call this as a peroxomonoic acid. Now let us see these again once again with the formulas for the oxoacids of phosphorus. So now let us derive the oxoacids of phosphorus with this plan that we have learned. So we will be starting with the parentic acid. So what is going to be parentic acid for phosphorus? It is going to be phosphoric acid with the formula H3PO4. And from the parentic acid, if you want the parent us acid, what are you going to do? -1 oxygen. So -1 oxygen from the ic acid, you get us acid, and from phosphoric acid, H3PO4, 1 minus oxygen is going to be H3PO3. So that will be phosphorus acid. From phosphorus acid, we are going to subtract 1 oxygen to get hypophosphorus acid. So that is going to be H3PO2. Next, what did we do? We subtracted 1 water from the phosphorus acid. So 1 water minus is going to be H3 minus H2, 1 hydrogen left, 1 phosphorus and 2 oxygen. So that is going to be HPO2. So this will be called as metaphosphorus acid. And on similar side, we can remove 1 water from phosphoric acid to get metaphosphoric acid. So that is going to be HPO3. Here we have written a X in the footnote for this because this does not exist as a single monomer. It is going to exist as a polymeric unit of HPO3. Okay, so this is going to be HPO3X, not singly HPO3, not existing. Fine. All right. Next, what did we do? We multiplied this us acid by 2 molecules and then subtracted 1 water. So what this means is that you are going to multiply all the numbers of hydrogen, phosphorus and oxygen by 2. What you will be getting is H6, P2 and O6. And from this you will be subtracting 2 hydrogens and 1 oxygen. So what you will be getting is H4, P2O5. And what will be this called as? This will be called as the pyroous acid, that is H4P2O5, or it is going to be called as the diphosphorus acid. Alright, now similarly we can do this for phosphoric acid also. Multiply that by 2 and subtract 1 water molecule from that. What you will be getting is pyrophosphoric acid with the formula H4P2O7. Alright, so this was H3 into 2, 6. 6 minus 2 is going to be H4. P into 2, so that is going to remain, so P2. Oxygen, 4 into 2 is going to be 8. 1 oxygen gone, that will be O7. H4P2O7 is pyrophosphoric acid and also called as diphosphoric acid. Next, what did we do? We added 1 oxygen to phosphoric acid to get peroxophosphoric acid, right? So this is going to be peroxophosphoric acid, H3PO5. All right, and here what are you going to see? You are going to see a peroxide linkage in the structures when we will be writing down the structures for these compounds. Now this is just 1 unit of phosphorus, so it is also called as peroxomonophosphoric acid also, or simply peroxophosphoric acid. Alright, next what did we do? Well, from the pyrophosphoric acid, we are going to subtract 1 oxygen and we are going to add 1 oxygen to get 2 more oxoacids. So the first one, when we are going to subtract 1 oxygen, is going to be diphosphoric acid now, right? So this is going to be hypophosphoric acid, that is H4P2O6. Fine. So we simply called it as hypophosphoric acid. We do not use di, but you just have to remember that it is not from 1 molecule of phosphoric acid that we are removing an oxygen atom. When we remove just 1, you will be getting phosphorus acid. And next, when we are going to add 1 oxygen atom, what we will be getting is a peroxo diphosphoric acid. Okay, so peroxo or peroxy diphosphoric acid, and the formula for this is going to be H4P2O8. Clear? Perfect. I hope no problems in learning this. So we have, just let us repeat it quickly, that we have phosphoric acid H3PO4. When we are going to minus 1 oxygen H3PO3, this will be called as phosphorus acid. Minus 1 oxygen hypophosphorus acid H3PO2. Minus 1 water, you will be getting metaphosphorus acid HPO2. Two molecules minus one water is going to be pyrophosphorus acid H4P2O5. This is also called as diphosphorus acid. Phosphoric acid side, when you're going to remove one water, you will be getting metaphosphoric acid. Removing two molecules, you will be getting pyrophosphoric acid or diphosphoric acid. Add one oxygen, you will be getting peroxomono phosphoric acid, and from the pyro, when you're going to subtract one oxygen, you will be getting hypo, and when you're going to add one oxygen, it is going to be peroxodiphosphoric acid. Right? I hope now all the names and the formulas you can write it out yourself. So that would be all for this lecture. I hope you enjoyed your learning with me, and in the upcoming lectures there are going to be more tricks coming up, more concepts coming up, and more questions coming up. So please do subscribe to the channel and click on the bell icon so that you get a notification the moment the next lecture is uploaded for you. And if you've liked the lecture, please do click on the like link and also do share it with your friends. And one very important thing, if you have any doubts, please put your doubts in the comment section. And if you cannot put that in the comment section, if there are questions which you want to discuss with us and clarify your doubts, you can also mail them as us to h2ochemistry@gmail.com. So see you again. I hope you're going to study very hard and be successful in your upcoming examination. Bye bye. Have a nice day.